Hello, everyone. Welcome to another lecture. So this is lecture number 16, and this is the start of the three lectures on statistics. Okay, why we do people need statistics is because when an example you already collect the sample, you do your test, you get your results, right? So these results from various samples that you test will be tabulated, will be stored, and then companies may use this data to check how stable their product is, whether it deviate from the mean or there's some issue and so on. So that's why statistics here is actually the last part where people study the trend of the results, okay, of from the tests that they do on the samples. That's why this statistics is part of this sample handling and processing, the processing part, processing the data now. Okay, so we'll just take a look at the first lecture on statistics here. So this one is more on the data, which is in the center, okay, central tendency, and also how widespread the data is. So what kind of terms they use to see whether the data are close to the center or your mean, and how widespread it is around your mean. Okay, so we'll take a look at some of the terms people use in statistics. Okay, so these are the terms that we're going to cover, okay, to measure your data. Okay, we'll take a look at the mean. There's another one, median, and mean versus median. And there's another one called mode, right? Okay, so the center part, central tendency is the middle part of the data. Okay, so that's why your mean, your average, when you calculate, right, is always in the center. Then you have another one, median, which also measures the center part of data. And there's another one called mode. Okay, so for mean, basically it's your average lah. So it's quite straightforward. So you get the average value of your data points. All right. So how to calculate the mean? So in SHB, right, in terms of sampling, okay, remember these terms here, sample and population. Population is the big area that you're going to collect your samples from. So sample is the smaller part of the population. So basically the symbol used for a sample is X bar, and the population is mu. Otherwise, it's all the same. And the n, okay, the number of samples that you test, n. For sample is n. If you test the whole population, it's big N. Okay, that means you do complete inspection. So that's a population. So it's big N. Regardless, the calculation is the same. You just total up all your values, divide by the number of values that you have. Okay, simple. It's just average. Okay, let's go through this example. So difficult, right? Okay, just plus them out together, divide by the number of data, which is 5. And you get your average. So difficult. Okay, the next one is called median. It's the 50th percentile. That means it's still in the center. Okay, middle number. The key thing here is you must write out your data in order from the smallest to the biggest. This is the difference. For median, don't forget to write from smallest to biggest first. And then you see your data after you arrange them in order. And then you take the average in the center of your data point, like this. Okay, this one is already nicely arranged already from small to big. Okay, then you take the center number. So 1, 2, 3, 4, 5. Center number is 36 here. So that's why your median is 36. In the case whereby the number of data is even, like this case, right? 1, 2, 3, 4. Okay, you don't have a center number like the number in the third number here. Okay, so you have to take the mean or the average of the two center number. If it's odd number of data, it's on 5, right? 3 is quite clear cut lah. So you just take this number. But if it's even number, you have to take the average of the two middle numbers here. And you get 157. So that is your median. So just take note of this. Okay, this is some theory about the differences between mean and median. Okay, so they are different and they are the same. So similarity is they are about the center. it is the symmetric about the distribution. That means from the center, right? Both left and right side of the center is similar. Okay, the difference is this. For mean, right? For median, they are more resistant to outliers. Okay, later we'll take a look. What is outlier? This is an outlier. Okay, usually, right, the numbers that you get are all close to the mean. But then there's always some cases whereby some data, right, the don't know what happened, the number is way out from the normally where it lies from. Okay, like this one. So these two are actually the outliers. Okay, whereas the rest of the data are quite close or close by your mean. Your mean is the straight line here. So this is what we are saying. Okay, so for mean, right? Let's go through mean first. So let's say we calculate what's the mean, 7.57. But then now, if let's say you have an outlier here, which is 150, like way bigger than the rest, right? So this is your outlier. So your mean will be affected. It suddenly becomes 26. Whereas if you have a median, right? Because remember we arrange from small to big and then we take the center number. So in this case, the center number is 7. Okay, so the median is just 7. So it's not affected by any outlier because the outlier is on the either on the left or on the right side. We only take the center one. So this is one of the advantages of median. Okay, so some people say median is better, but in most cases, best to report both lah, mean and median. Okay, mode is straightforward. Mode is the number that comes out the most number of times. That's all. So in this case, 5 come out 3 times, right? So your mode is 5, the most popular one. Please take note, when people ask you mode, it's not the number of times it appears, okay? It's that number that appears the most time. So 5 appears the most, so therefore it's 5. Don't write 3 because it appeared 3 times. Okay, take note of this. So of course, mode is very unstable. Okay, because it's affected by outliers also. Okay, so if two of the numbers both come out the same number of times, then it's possible that you have a bimodal. That means two modes. Okay, so mode is where the number appears the most number of time. Okay, so the number that appears most number of times should be in the center of a distribution curve. Okay, we get back more to this later lectures. Okay, let's do this very quickly. Okay, so just calculate the mean, right? You should get this. Median, rearrange first. Don't forget, this is not in order, but regardless, if you rearrange, it's still 23. Median, 23. So you can see here that the mean is affected by the outlier, which is 143. Whereas median, still the same for both sets. Okay, this one you go through on your own. Okay, try it out. You should get these values. Same here. Okay, these are all the answers. And that's all for central tendency. Okay, let's move on to spread. So spread will tell us how widespread your data is along the mean. Okay, how wide it is, how far it is away from your mean. So the terms we're covering will be range, variance, and standard deviation. So these terms, right, will tell you how widespread your data is. And then we also cover this interquartiles. So this is telling you that sometimes just the mean alone is not enough because we don't know how the data is spread out. Okay, the mean is just the final center value only. So spread is how widespread the data is. So in this case, A is more widespread and it has a higher variation. So here is an example here. So the mean is actually the same if you calculate, but it doesn't tell you how widespread the data is, right? Okay, you only know 1880, but you can see class B is more widespread. Okay, so it tells you how widespread it is. So the best is you have to have both central tendency, just now we covered earlier, and the measure of spread. So must be both together to give you the best statistics. Okay, both center and the spread. So we'll be taking a look at all this: range, interquartiles or quartiles, variance, and standard deviation. Range is very simple. Just take the highest value in the data set minus the lowest value in the data set. Finished. Okay, so this is an example. So 42 minus 3, biggest minus small, right? Data set B, 6 is the biggest, minus small, 3. So you can see here that definitely range is affected by outlier. Here 42 is the outlier, right? Because it's way bigger than the rest. So range is definitely affected by the outlier because you take the biggest value. So it does only depend on 2 points only. Okay, interquartile range. Okay, this one is the median, based on the median, and then you calculate the interquartile range. Okay, don't worry so much about this. Let's go later to the calculation. So it describes the middle 50% of the data values. And as mentioned just now, since you are based on the median, interquartile is based on median, right? So it's not affected by outliers. Okay, let's take a look at this. Okay, so you can see here, they ask you to calculate the median, lower, upper, and interquartile. So all these three are related, all the quartiles. Okay, so when I talk about quartile, you have to come from the median, which means to say you have to rearrange this data set from smallest to biggest. Okay, so you rearrange. So when you rearrange, don't forget to make sure you don't miss any numbers. Okay, then after that, you find the median. So how many data are that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 numbers. So it's odd number. So the center one will be your fifth number. So it's 24. Okay, so that's your median. Now they ask you to calculate the interquartile. But in order to get interquartile, you will need the lower and upper quartile first. So is the lower quartile? So lower quartile, right, is from the median, which is 24 just now, and smaller. That means the lower half of the set from 19 to 24. That means from the lowest value to your median here. Okay. So once you get this set here, this is your lower quartile side. So to calculate lower quartile, you get the median of the lower half of your set. That is lower quartile. So lower quartile is actually the median of this lower half. So we have 19, 21, 21, 24. Since it's 4 number, right? So it's even number. So there's no distinct middle median. So you have to take the average of 21, 20, which is also 21 lah. So that's your lower quartile. Next, we move on to upper quartile. Do the same thing, except it's for the higher set of values here. So same thing again. Okay, so the set is from 24, 25, 28, 30. Then get the median. So it's 25 plus 28 divided by 2, which is 26.5. And then finally, you can calculate interquartile, which is upper minus lower quartile. 26.5 minus 21. Okay, so the interquartile is actually from 21 to 26.5. So interquartile, this is the calculation. Okay, so if you go back to just now, what we skipped, right? This is the formula. Upper quartile minus lower quartile become interquartile. It's always all related to each other. The median, lower and upper, and finally interquartile. All right. This is another example. Rearrange. So now you have 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So now there is no distinct median really. unlike the earlier example. 24 is your distinct. So now you don't have because it's even number. So therefore the median will be 21 and 28 divided by 2, which is 24.5. Okay, so it'll be 24.5 will be here. Okay, repeat. So the median will be, sorry, just nothing I say wrongly. The median will be 24 and 25 divided by 2. Okay, so it'll be, because it's even number and there's no distinct middle number here. So you have to take the average of these two to get your median. So it's 24.5. And then 24.5 is here, right? Even though it's not mentioned there, so it's the center here. Okay, now again you take the median of the lower set and the median of the upper set, which is your lower and upper quartile. So 21, 21, this is the same. This one is 25, 28, 26.5. So inter will be 26.5 minus 21. So it's still 5.5. Okay. Okay, next one we'll take a look at variance. So basically what variance means is that how widespread your data is. So if your variance is high, right, it means that the spread is way everywhere around the mean. It's further from your mean, from the center. Okay, low variance means it's all quite close to your. Okay, so this one very cheap. Okay, so basically, so you see here, right, there's two kinds of variance. One is population variance, the other one is sample variance. The only difference is divide by the number of data. For population, divide by all, the n number of data. For sample is n minus 1. Okay, so that's the only difference. The rest is, we will take a look later. You have to do the sum of your data minus mean, square it. Very cheap, okay? So this is how people calculate variance. And standard deviation, once you get the variance, it's easy already. You just square root your variance, done. So variance is the troublesome part. Okay, you can see here, square root of variance, done. So if your variance wrong, there's the standard deviation also wrong. Okay, so before we enter into the calculation, this one just some theory about it. Is how standard deviation is how widespread around the mean. It's never negative because of the formula here. Square it. So if this is a negative, you square it, become positive. And it's sensitive to outliers. Greater the spread, greater the standard deviation and variance. If standard deviation is 0, means all your values are the same as the mean. Okay, there's no widespread. Okay, this one is the earlier example, the practices. Okay, so you can go through from the example we gave just now. Okay, and these are the answer. You can do it on your own because we want to take a look at the other one. Okay, this is the working. Okay, you can look at the teacher's copy of your file to see all the working if you still don't know. Okay, let's take a look at this. Calculate the mean, variance, and standard deviation. Please take note that this is not interquartile. This is not median. Okay, interquartile median, you have to rearrange. This one, you don't have to rearrange. If you want to rearrange, also fine, no harm. But you don't have to waste your time to rearrange. Okay, so the mean, okay, no need to rearrange, just blah, 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 add, divide by the number of data, which is 8x, right? So divide by 8. Okay, there should be 8 data here. You should get 59. Okay, now is the part where we calculate the variance. Okay, the formula just now, don't know what are all the symbols. So basically it is, okay, this is the answer 40, yeah, but the calculation is this. First data, 60, minus the mean, 59, square it, plus next data, 56, minus mean, square it. Next data, 61, minus mean, square it. And then you do the same for the rest of the 8 data, plus, all the square of the difference, and then you divide by 8 because there's 8x here. Okay, for those of you who are very sharp, okay, if you see the formula, population is divided by everything, sample variance is divided by n minus 1. So just now you have 8x, okay, so we divide by 8. Why not divide by 8 minus 1, which is your sample? Why divide by 8? Because the hen lays 8x. You take all the 8x to weight. So this is a population. Okay? If the hen lays 100x, you take 8x out from the 100x to weigh. That 8 is a sample. In which case, you should divide by 8 minus 1, which is 7. So please take note the difference between population and sample. In this case, it is population because the hen lays all the 8 eggs, and then all the eggs you go and weigh it. So this complete testing. That means you test for the weight. Okay, complete inspection for the weight. Okay, so if you say the hen lays 10 eggs, 2 eggs was taken out to as sample to weigh, then that 2 become a sample. In which case you have to divide by 2n minus 1. Okay, which is 2 minus 1. So please take note of the difference between the population and the sample. Because the variance is 1 is divided by n, 1 is divided by n minus 1. Anyway, if you do all this, you divide by 8, that's your variance, which is 40. So what you should do is you square root the 40 to get your standard deviation, 6.3. All right, so try it out and see whether you can get it. You got any question, please check with us. All right, thank you.